When KIP-500 was new, I want to say August of 2019, I had Jason Gustafson and Colin McCabe on the show to talk about how we thought it was going to go, what the plan was, how long it would take, what the steps would be, all that kind of stuff. Well, now that KIP-500 is merged and released in Apache Kafka 2.8, I had those two guys back on the show to talk about how it's gone. So we'll dig into it in some detail on today's episode of Streaming Audio, a podcast about Kafka, Confluent, and the cloud. Hello and welcome to another episode of Streaming Audio. I am, as always, your host, Tim Berglund, and I'm joined in the virtual studio today by my colleagues, returning guests here on Streaming Audio, Jason Gustafson and Colin McCabe. Jason and Colin, welcome to the show.
Thanks, Tim. I'm happy to be here.
Yeah, it's great to be here.
And back, as I say, the triumph of hope over experience, right? Anyway, we were talking, the last time you were on, we were talking about KIP-500 because it was this bold new KIP and this project we'd embarked on. And that was, I want to say, a year and 8 months ago. I think that was August of 19. We're going to have a link to it in the show notes, so we'll know. That's a historical record. And KIP-500 has been merged, so we're back. What does that mean? Where actually are we?
Yeah, that's a good question. I think, I was trying to recall when we had our last podcast. I guess it was pre-COVID days, so a year and 8 months is probably on target, but it feels like it hasn't been that long. So since then, we've made a ton of progress. In the last podcast, we talked about the overall architecture that KIP-500 brings. We talked about the Raft implementation. We probably talked a little bit about the controller and its mechanics and all of this. So since then, a lot of the big pieces have, we've done the KIPs, they've been approved, and the code has been even merged. So let me just give a quick summary, and Colin can add some details about the progress. So, we did a KIP for the Raft protocol. So we merged that last year. We've been testing it quite a lot since then. We did a KIP for the controller, basically the design of it, including what are the records and how we reason about the state in the log and all of this. So that also has been checked in. Colin, do you want to talk a little bit about maybe the 2.8, what we have?
Yeah, so that's a good summary. Basically, we had some pretty important foundational KIPs that filled in the details of KIP-500 as promised. You mentioned a few of them, the KIP-595, the Raft implementation. We had another one for snapshots, and we had obviously the controller one, KIP-631, as well as the one about redirection. I think that for me, the most exciting one was definitely the controller one, just because I really like the idea of redesigning the controller for scalability. But the other KIPs were, in their own way, equally important. And especially Raft was super exciting too, because, we took Kafka into the world of Raft. And, at the beginning, like we knew that there were lots of similarities between the Kafka protocol as it stood and Raft. But we didn't know exactly how everything would work out. And I was really happy to see everything come together. I think it came together really well there.
Nice.
So anyway, I should also talk a little bit about what you can actually do with 2.8. I mean, our users probably want to know that. So we have this early access, early access mode of KIP-500. And what early access basically means is don't use it in production. Don't do it. But do take a look, test it out, kick the tires, and see where it's going. It's sort of like basically like it's a preview, right, of what we're doing. It allows us to iterate on where we are. So basically, the stuff we have working right now is like we have produce consume working. obviously the most fundamental thing of Kafka. We have a bunch of different APIs related to topics are working, creating topics, deleting topics. You can describe various things about topics. Um, there's a surprising amount of little
And
features
those
that are
have
completed.
been
Go ahead.
APIs that have kind of been creeping in, right? The
Um,
additional admin APIs for doing things with topics, and it seems like they've been
yeah, so I mean, we've added those APIs over
leaking
time.
in.
Exactly. I mean,
Yeah,
we've added those APIs over time as Kafka has gotten more, um, more. What's the word? Uh, we wanted to make
cloud
it
native.
more what? Yes.
Cloud native. I mean, that's they always seem to me like
Oh yeah. Well, cloud native is definitely a
cloudy sorts of
good.
things.
I mean, adding the APIs absolutely made Kafka more cloud native. I would say, like just in general, becoming more battle tested and more production ready. Having like a very stable API that you can depend on is part of that, rather than just modifying things in ZooKeeper directly. That was basically, when Kafka originally started, you would just modify stuff in ZooKeeper directly. And it was all very tied to like a specific format. So when you upgraded, maybe that format was a little different. So you'd have to use the right admin tools. Um, Over time, we've come to realize like the importance of APIs to our users and just in general to building the system. And we've gotten much better at that. Um, any new feature in Kafka right now comes with a discussion of compatibility. How does it interact with upgrade? You know, and obviously people are going to be thinking about how this works in the cloud as well as on premise. Obviously, when Kafka was first created, it was the very very early stage. It was more of a proof of concept, but that was a long time ago. So, but anyway, having these stable APIs has allowed us to sort of switch the backend and replace your old ZooKeeper backend with your new shiny new KIP-500 backend, and hopefully, as with the old coffee maker jingle, hopefully you can't tell the difference, or it's even better with the new.
Yeah, in fact,
Is that for decaf?
Oh,
That was a
definitely not
decaf
decaf.
jingle.
I can tell the difference there.
Yeah, I assure you, I'd be able to tell the difference. KIP
yeah, I think,
500 is not decaf, everyone.
it's been so long since we had this, since we did the last podcast, that yeah, I think I recall that a big part of that discussion was how do we take those old APIs that we had that were kind of reaching into ZooKeeper directly and mutating state and replace them with APIs that are at the Kafka level. And so I'd just kind of forgotten, but yeah, most of that work was completed probably a year ago or so.
Mhm.
They're like basically some stragglers in terms of full support, but yeah, we that was a big part of it, and that kind of reaches. There are a lot of ways that the old architecture kind of ended up getting exposed through APIs in ways that kind of made this migration a little bit difficult. So let me just give one example of that. So with the old in the old ZooKeeper world, the brokers, they all had access to ZooKeeper. So they all were able to, accept any APIs which could mutate state. So, for example, a user comes to the broker and says, "I want to, change some configuration for some topic." You don't have to find any particular node to do that. Any one of the brokers can reach into ZooKeeper, update the state, and everything's fine.
Mhm.
So with KIP-500, of course, that's no longer exactly the case anymore, or at least not directly, because there is no ZooKeeper, so
For
there's
one.
no way to access. So what we had to do in this case is, actually introduce a mechanism for forwarding requests. So we have to be able to take the request from the client, and we send it off to the Raft quorum where the change is actually applied. So it's analogous, but all of this stuff requires a considerable amount of work.
Absolutely. And it's been fun over the past year and a half. I'm not a committer, but I'd certainly keep up on at least the major KIPs in each release. And I make videos about each release, so like I have to understand what those things are about. And it's been cool to see just the little bits of connective tissue between brokers and ZooKeeper kind of getting cut away a little piece at a time. And each one's small. It's some little admin API. It's no big thing, but here's a cleaner way to do it. But clearly a part of the master plan.
Yeah, that's exactly right. That I think it's what makes a project like this so difficult is that you have to. There are so many places in the code where this expectation of having ZooKeeper there just it allowed people to get to something that worked much faster, so people took advantage of that. But every single one of those little things, they actually kind of turned into a project of their own. Like, how do we before, for example, we have, some extensions for, JBob, just a bunch of disks, where, we would rely on ZooKeeper to propagate changes to the controller. But that in itself, basically you kind of have to redesign that feature when you no longer have ZooKeeper anymore. So even though these little pieces, they seem small, and they are, and sometimes they are small, but they're every one of them has to be dealt with, which is why this project takes such a long time to get to completion.
Right. So the controller, the new controller, I know we in our podcast of 600 years ago, we talked out. You kind of sketched out what it would look like. Walk us through that again, and to whatever extent is necessary, tell us about how that contrasts with the way it used to work. So what's the situation?
Yeah, good question. So the way the old controller works is basically it uses ZooKeeper as its backing store. However, it's not the only entity that can access ZooKeeper. So the old controller has to treat all of its modifications to ZooKeeper as kind of provisional or conditional. Like it has to check what's there and do sort of a transaction. So it's a little bit like you're accessing the database, but maybe someone else is too. So it makes it a little bit hard to have the most up-to-date information about what's going on in the cluster. Because really what you want is you want that local cache of what's in memory. So you can do things quickly. And so you can also have the information at hand to do whatever you want to do. In the new controller, so I guess from the 10,000 foot view, I would say from the user's point of view, the biggest difference is you have standby controllers now. So you typically would have either 2 or 4 standby controllers in addition to your primary controller. And those standby controllers are ready to take over if the primary controller fails. And they can do that without having this lengthy loading process that the ZooKeeper-based controller did. And that's again because we've integrated the data store with the controller itself. So all of these standby controllers will be following along with whatever metadata modifications are happening, rather than having to load it all in sort of a big bang fashion if a failover happens. So one thing that's really exciting is the ability to do
locally cached copy.
Yeah.
You used to have to go and read a thing out of ZooKeeper and have a locally cached copy, and now the locally cached copy is the metadata. I mean, it's the state.
Yeah. So I mean, I guess one simple way to put it is ZooKeeper doesn't have a way to like follow all the changes, right? You can follow a particular Z node. You can even follow like the children of a Z node, but you can't get all the changes. So there's always going to be something that you miss. And that makes it really hard to do a standby with that architecture. I don't think it's impossible, but I do think it would be very hard, and you would end up with an architecture that doesn't really feel very nice. But in the case of KIP-500, you actually do have that full in-memory state. It's just slightly behind, right? So once you replay the latest updates, then you're fully up to date. And because of Raft, we have this guarantee that when an update has been committed to Raft, that means a majority of the controller nodes have that change. And the next leader must be chosen from one of those nodes that has the change.
Got it.
Which is, again, pretty much the same guarantee ZooKeeper has with their ZK protocol. But it's just that by integrating the logic of the controller with the Raft logic itself, we have something which is sort of more than the sum of its parts.
So for now, you stressed that this is not for production use, and that's I think very clearly communicated about 2.8, at least just when 2.8 is released. Like, no, seriously, don't do this. And that's cool because it's new and large, and we need more miles on it. We need more testing, but also not every feature is there yet. So what does just thinking specifically of 2.8, right? We're kind of ringing this bell saying, hey, KIP-500's merged. It's okay. It's all over now. But there's still a phased implementation here. So what can we do now and what can we not do now in 2.8?
Yeah, that's a good question. What I'd say we've done so far is kind of the most significant parts, I think, are probably the Raft implementation and the controller. But there's kind of a long tail here of additional features that we kind of have to build into the system. So what you can do right now in 2.8, you can start up a cluster without ZooKeeper. You can start it up with, you can run it as a single node, for example. You can run it as a quorum of 3 nodes or 5 nodes or whatever. So you can do all of this. What we support today is basically like, you can create topics, you can write to them, you can read from them, and you can delete them. There's a bunch of administrative stuff which you cannot do. So, for example, a lot of the stuff around security. So, the ability to change Scram credentials through the new controller. We just haven't gotten around to implementing that API. And there are a few things like this. I think partition reassignment is one of the ones. We were hoping to get this into 2.8. We couldn't quite get it there. So I think this is going to come along the way. And there's some smaller ones. To use EOS, for example, we depend on this logic that we use to have unique producer IDs. We just didn't quite get that to in the new controller yet. So
got it.
So basically, you can't use EOS yet, but that was another one that was kind of disappointing. All of these ones are not large in terms of the amount of work, but there was just not enough time to get it into 2.8. So what you can do, create topics, write to them, read from them, and delete them.
Yeah, we have a long list of things that we're going to follow up on. EOS is definitely one of those. Partition reassignment, definitely one. JBOD, the ability to have multiple data directories that span multiple disks. That's something we're going to have soon. We don't have it yet in 2.8 for KIP-500. Definitely security. There's a few things we want to follow up on there. We don't have the ZooKeeper free authorizer yet, which we will soon. So yeah, those are just some examples of the things that we don't have yet that we will soon.
Sure, plenty of work to do yet, but the core of the thing that replaces ZooKeeper is present, and that's awesome. That single node thing that you mentioned, and that's like, if you hadn't thought of that as some independent thing, it makes perfect sense now. Like, why wouldn't you do that? It's easy to maintain easy to achieve consensus. You're always consistent, and you don't need a ZooKeeper hanging around by definition. So that's kind of cool. That sounds like that would be handy for, like, heavier weight integration tests and tutorials. And I don't know. And we're speculating, so this isn't like backlog or commitments of what the project is going to do or any sort of Confluent opinion. But what else would you do with a single node?
Yeah, that's a good question. I think well, the one you mentioned there is sort of what we've already started doing. So integration testing. So a lot of our integration tests, we do use a single node just for convenience and for it's cheaper and it's faster. But I think also this has been an ask in the community for quite a while to have sort of like a standalone Kafka. I think where I've seen this is in sort of like edge use cases. So like IoT, for example, where basically like you've got a lot of uh, remote sensors or remote things which need to kind of ship data into some centralized place, and oftentimes these are kind of constrained systems. You don't necessarily have enough to be able to build like a 3-node quorum or something like this. Basically, you're just kind of using it as like a temporary staging point, like where you can you've got some expectation of unavailability in that just because of the network. And so you can kind of stage your changes all in a edge Kafka single node, and then as like the as network access is available or whatever, you can push it to the centralized place. I think that's a pretty common place that I've seen it.
I personally am going to run that on a Raspberry Pi before too long, so don't worry. I mean, I'm sure it's been done already, but that's just too good. And yeah, you have like a simplistic sort of, doesn't have to be Kafka Connect, but basically a connector that when you get connectivity, you consume from your local thing and produce to the faraway cluster.
Yeah, I think that in general, scalability is obviously it means scaling up, but sometimes it also means scaling down. And the Raspberry Pi or Edge router or other example like that is a great example of that. So having like one JVM rather than two, I mean, yeah, sure, when you have a beast of a node, it doesn't seem like a big deal, but it actually can be a big deal with certain applications. And another thing that we have with KIP-500 is we're going to give people the ability to run with 3 nodes rather than 4 and still be able to roll effectively. And this probably requires a little bit of explanation.
Tell me about that.
So currently, a lot of people will run with 4 nodes rather than 3, only for one reason, which is that when there's a roll going on, there's actually only 3 nodes available most of the time because one of them is going down.
Like a rolling upgrade.
Right. And so if you choose to create all your topics with replication factor 3, which most people do for safety, you will not be able to create any topics if you only have 2 brokers out of 3 with the current system. But with KIP-500, we actually would like that to be possible. And this is possible because we now retain the memory of that node, which we didn't before. So in the old system, when a node went away, there was kind of no record of it ever being there. You were either in the cluster or you were out of the cluster. We've actually added a third state with KIP-500, which is you're in the cluster, but you're not available currently. And adding that third state makes it possible to even place new topics on that node, which isn't available now, but we expect it to be available soon.
I think this is a really good example of we could have implemented this on top of ZooKeeper as well, but this is a good example of kind of the ways that as we were designing KIP-500 architecture and kind of breaking down these points. There are a lot of things in Kafka which people kind of take for granted, like, well, just the implementation is that way. It's always been that way. Why would we ever want to change it? So I think, but as part of KIP-500, we're kind of forced to break that down and say, okay, what is this doing? Is it doing the right thing? Even what could we improve there? And I think this is a nice case where just as a part of this redesign, we're able to kind of remove some of these limitations that we had previously.
Absolutely. How about performance? I know the sore spot has always been failover in the presence of a large number of partitions. That's kind of the thing that's got the spotlight on it. So tell us about that, obviously. How has that worked out? And what other performance implications have you been able to measure so far?
Yeah, that's a good question. I think Colin talked a little bit about the way that now we have these standby controllers. So the big difference is that everyone in the cluster, all the nodes in the cluster, they all see the same stream of events and in the same order. So all the nodes in the cluster can basically build up the state incrementally. Whereas in the old controller, you got this, after a controller failover, you need to do this state reloading thing. And the big problem is that, this is the complexity of this operation is big O, the total number of partitions in the system. With the new controller, you don't have that anymore because the changes are being applied incrementally on all of the controllers that may become or standby controllers which may be elected. I think we've done some preliminary testing. I think we've gone up as many as a couple million partitions. So I think what we've observed is with the old controller, with the ZooKeeper based one, that controller failover can take like more than 20 minutes, something like this. So it's just totally infeasible to run a cluster with that many partitions with that architecture. With the new one, controller failover is nearly constant time. The only exception to that is you kind of have to wait for the time for the controller itself to detect that the old one has failed, and then the other one will hold an election and it can pick up.
Yeah.
But our performance testing shows it's quite bring that down to basically the cost of that detection time.
Got it. And that's necessarily it's not microseconds, folks. That's not how this works. That's on the order of tens, small number of tens of seconds, at least is the data that I've seen, to detect that the thing, that something is broken and you have to fail over. But the actual failover is that fast. That's awesome.
Yeah, we've been looking at different numbers for failover. I think that this is something that we'll tweak, and we'll just learn by doing to some extent what numbers work best for failover. I've been pushing for low numbers. There are trade-offs, and it may also depend on the application. But my hope is that the controller failover can be so cheap that we can even be a little aggressive and maybe reduce that. Because if we have a failover we didn't necessarily need to do, maybe it's not that big of a deal if failover is cheap. So wherever possible in the system, we've been trying to replace things that are order n, where n is number of partitions or number of topics, with things that are order 1, constant time. And obviously controller failover is one example of that, with a hot standby. Another example is just when you first boot up the broker, we would like to actually have that information about metadata cached on the broker right there. And we're sort of, we have that now with KIP-500 because you actually have that metadata topic present when you start up. So this is a first for Kafka, right? So durably persisting the metadata onto the broker. Definitely not something we used to do, and it's something we do now. And there's a few things we need to do to optimize that. Actually, one thing that I guess I forgot to mention earlier, we didn't manage to get in loading snapshot support for the broker, which is another big omission in 2.8, coming very soon. But as soon as loading snapshot support is there, we expect that actually to be pretty quick for our broker startup.
Last question, and almost at time here, but what's next? We've talked about what isn't happening yet in 2.8, but what should we look forward to in the future, in as much as you can speak to that?
Yeah, I think there are two things that are kind of central in my mind. So one of them we've already talked a little bit about, which is just kind of dealing with this long tail of features that just we have to get done. I'd say the other big thing is actually getting some production experience and start get this deployed for example to Confluent Cloud, and start soaking it, do load testing, do all of this stuff, start getting some experience with the timeouts, as Colin was talking about. Basically start turning it into building some working experience with it, and tuning it, and ensuring its behavior and all of this stuff, so that we start having some confidence. So by the time 3.0 comes out, we can say, well, we've been at least soaking it for several months or something like that. So I think these two things are foremost in my mind.
Yeah, definitely. I would also add we're going to do a lot of work on making upgrade work smoothly, so that you can actually migrate your data from ZooKeeper a ZooKeeper based cluster to a KIP-500 based cluster. That isn't there yet, but it will be soon. So that design is still in the future.
My guests today have been Colin McCabe and Jason Gustafson. Colin and Jason, thanks for being a part of Streaming Audio.
Thank you, Tim.
Oh, thanks, Tim.
And there you have it. Hey, you know what you get for listening to the end? Some free Confluent Cloud. Use the promo code 60PDCAST, that's 60PDCAST, to get an additional $60 of free Confluent Cloud usage. Be sure to activate it by December 31st, 2021, and use it within 90 days after activation. Any unused promo value after the expiration date is forfeit. And there are a limited number of codes available, so don't miss out. Anyway, as always, I hope this podcast was useful to you. If you want to discuss it or ask a question, you can always reach out to me on Twitter at @TLBerglund. That's TLBERGLUND. Or you can leave a comment on a YouTube video or reach out on Community Slack or on the community forum. There are sign-up links for those things in the show notes if you'd like to sign up. And while you're at it, please subscribe to our YouTube channel and to this podcast wherever fine podcasts are sold. And if you subscribe through Apple Podcasts, be sure to leave us a review there. That helps other people discover it, especially if it's a 5-star review, and we think that's a good thing. So, thanks for your support, and we'll see you next time.